Hey guys, I hope you're doing well. I make organic chemistry video tutorials, so if you're new to this channel, feel free to subscribe. In today's video, I will talk about elimination reactions. If you haven't watched my previous video on substitution reactions, I would recommend you to watch that. There are two types of elimination reactions, E1 and E2. Let's look at the E1 mechanism first. There are two steps in E1 mechanism. In the first step, here we can see bromine is leaving from the haloalkane, which is our substrate. The carbon to which the functional group bromine attached called the alpha carbon. The adjacent carbons are known as beta carbons. So in this step, a stable carbocation will be formed, and the bromide ion, after leaving, will be somewhere in the space. Then we move on to the step 2. In this step, we need a base. In this example, our base is methanol. The lone pair on the oxygen atom is taking a hydrogen off of the beta carbon of the carbocation. So the electrons between the carbon and the hydrogen will form a double bond. The methanol forms a new bond to the hydrogen atom, and the oxygen of the methanol will gain a positive charge. Remember, in E1, the formation of the carbocation is the key factor, and that alone determines the rate of the reaction, or the reaction speed. Once the carbocation is formed, the second step is easy to happen. Let's talk about the E2 mechanism now. Here we need a strong base, say ethoxy ion in this case, which takes a proton off of the beta carbon of the haloalkane, our substrate, and the leaving group bromine leaves at the same time. In consequence, a double bond is formed, and the bromide ion will be floating somewhere in the space. Our ethoxy ion takes the hydrogen and forms ethanol in this example. In E2, both base and the substrate, which is our haloalkane, determine the rate of the reaction. Now let's look at some comparisons. As we said earlier, the first step, formation of the carbocation, is the key step in E1. It is considered unimolecular. And in E2, deprotonation, or taking a proton away from the haloalkane or from the substrate by the base, and the bond breaking by the leaving group determine the reaction rate. So it is considered bimolecular. Tertiary carbon can form a stable carbocation and favors E1 reactions. But in E2, all primary, secondary, and tertiary carbon can take part if we have a strong base. Usually weak base is involved in case of E1. Stereochemistry for E1 is not that important because forming a double bond when you have a carbocation is easily possible. But in case of E2, to form a pi bond, that means a double bond, the hydrogen and the leaving group need to be 180 degrees apart from each other. That means antiperiplanar. Usually, we use protic solvents in E1 as the hydrogen of the solvent bonds to the leaving group. And in E2, we also use polar protic solvents as they are the solvent for the strong base. Now, what if we have to decide if a reaction will go by E1 or E2? Well, usually we follow the rule of the thumb. That means when you have a strong base, E2 will happen. As I said earlier, that E1 happens only when you have weak base, usually. So that's all for today. Subscribe and click the bell icon. See you next time.